separate. Hi, my name is Zack and today I'm going to be talking about our final project for mastering electronics. This is basically a voice scrambler, or sort of a voice hider if you want to call it that. So there are several key components of this system. The first is our white noise generator. We found this model of the circuit online and we produced it, and it basically it takes in about 12 volts and then outputs a white noise signal. We took this signal and amplified it so that it would be larger and usable. So that goes from here into this op amp right here, and this amplifies the signal. And then that output goes to the summation op amp right here, and this is going to take the combination of this signal and our second signal. So the second signal originally was planning to be some sort of voice using a microphone, but the problem was our microphone wasn't working and it wasn't picking up our voice correctly, so we think it might have just like broken, or we don't know. So we just decided to, for the point of this lab, just use regular sine wave input. You can still get the basic idea that we're taking the signal from the sine wave and from the white noise and putting them together. The voice would work just the same, so this is what we're working with. So our signal from the voice is going to go in, and then it's going to go through this low pass filter here. The low pass filter is set to about 195 kilohertz, or 195, yeah, and that, or 195 hertz, and that's about the voice range of about a human. So we kind of put it there so it'd make like sense. So this is a low pass filter here, and then following that, it's going to sum together here with our final, with our white noise, and that produces one complete signal. And here, we're going to learn about the actual...
Hey guys, this is Anthony. So I'm going to talk about like the actual outputs. So we use the wave generation function over here. Basically, I inputted a 50 kilohertz 5 volt peak-to-peak sine wave into the signal, and when you hear it through the speaker, it's like a really high like beeping sound basically. So this is our input basically, and then as soon as it goes through our high-pass filter, you can see that it kind of reduces the amplitude a little bit because we were inputting like 50 kilohertz, which is quite a bit. And then beyond that, we can look at the white noise machine, and if you zoom in over here, you can see the real changes. You can see that it's really generating about 1 volt of white noise in this portion. So then we grab that white noise, we go ahead, we amplify it, and then we sum it with the input signal. And you can see this is our final output signal over here. Again, assuming that we have voice, it would be very, very different. It would kind of shift a little bit. It wouldn't be so precise or so perfect as this kind of sine wave looks over here. But you can see that there is this white noise that's kind of being mixed with the sine wave that kind of creates like a scrambled output. We tried listening to it with the speaker. You can hear it very faintly in the background. It is like a much more hushed, and like it does have like this white noise like quality to it. Unfortunately, though, the speaker only is rated for like about 6 volts, and it's like outputting it around 5 volts. So it is still pretty hushed. It's not very loud. You can't really hear on a video, but you can see the output, which is what we did over here. So yeah, that's pretty much covers it. You can read the rest in the lab report, but thank you so much. This was great.